All right, so I thought we'd get started. My goal is just to go through a presentation for maybe an hour or so, and then ask questions and answer questions if they're burning questions as we go through it, and then handle all those at the end if we can as well. So just start initially by talking about what's kind of new at Implant Logistics, just to update you on what we're doing here. Last year we started building a new facility at Implant Logistics. This is a 30,000 square foot facility, and it's the distribution side of Implant Logistics and also the manufacturing side. So we make a lot of implants and medical parts and pieces for our company and other companies, but it's a pretty big investment that we made, and we're kind of proud of the facility. That's what it looks like if you were driving up to it in the wintertime. This picture was taken earlier. We really don't have snow in August in Wisconsin, but it's a combination of Implant Logistics and AMS Micromedical, the machining and manufacturing side of the business. So that's where the implants that you guys are using are manufactured today. And if you're in the area sometime, I'd be happy to give you a tour of that facility. Inside that facility is a lot of milling machines, 5-axis milling machines that make dental implants, medical parts and pieces. There's another room that's injection molding and whatnot. So anyway, that's what we've been busy doing for the last year and a half. It opened in August. I always thought myself in business, if you could solve a problem for somebody, potentially you can grow a business, whether it's in the dental practice or implant company or whatever investments that people spend their time and money on. I always think it's going to be successful if you can solve a problem for somebody and they're willing to exchange for that solution. So that's what I've always kind of moved my businesses in that direction. So in 2020, what's the implant view at the 10,000 foot view of implant dentistry? And I think we know some things, we don't know everything. What should we know? What are we still confused about? And there's always that question of how successful are implants, and it's personal in your practice, how successful are your implant cases? I think that's all of us as clinicians are always looking forward to do that. Anytime I do a presentation, you guys that know me are sick of looking at this slide, but this is really what drives me. I think in implant dentistry, these are the three things that I wrap my practice around, I wrap the implant company around. I'm always trying to figure out a way that we can help doctors solve and reduce these potential problems, because I think they are the three big problems in dentistry. Placement control with guided surgery is pretty much solved. Bone loss around implants, we have some solutions, not all to that. And then cost control and profit predictability, that's becoming more and more predictable as well. And we'll talk about a few of those things as we go through, but not in detail, but just cover the topics. All right, so again, my passion, my purpose in life, I think, is kind of that. So I personally invested in an implant practice and Implant Logistics, millions of dollars trying to chase a solution for that problem, as I showed you in a couple previous slides. So I'm pretty serious about it, and I think I've made some contributions, and that's really, again, what drives me in life, is to help solve those problems. So what's happening in 2020 to improve or help solve some of those problems? A number of things. But before we do any of that, let me show you some questions or topics that were of interest to you. So the doctors that signed up for this webinar a few days early, I added some of their questions into the presentation just so you can see that you may have the same questions I have, or they may be different. But Dr. Stempowski, for example, he wanted to know what screw versus cement retained restorations, which is better and why. So we're going to cover that a little bit in the presentation. Best way to ensure an implant is ready to be restored. And again, we'll touch on that as well, and we'll give you some good answers for that. Dr. Bill Poe, how about the new implant system? What's different from the old? And we'll touch on a few of those highlights or those points, not in great detail, but give you some idea of what's different about it and why we think we've improved the system quite a bit. Dr. Leanne Klum, how accurate is that radio wave implant wand to test for integration? So she's talking about the ISQ device, and we'll show you some slides on that and how to handle and how I use that in clinical practice. Dr. Smith, Eric Smith, digital workflow protocol for implant placement on fixed zirconia cases. So what are the restorative options if you want to go to zirconia? We'll touch on that too. What attachments are available and how do you use them? So those are the things that we'll cover in the presentation because you asked. Full arch implant reconstruction using Implant One, screw retained or cement retained. Dr. Calvin asked that, so we'll touch on those solutions as well with the implant systems that we have. Dr. Jacob Hamby, implant restoration techniques and planning. Again, we'll touch on that as well. Dr. Joel Crane, he didn't want anything, he just wanted to hear Leo talk. I hear the cynicism in that question. Joel's a good friend of mine. He actually is a dentist here in Wisconsin. I don't know if he's on yet or not, but Hopefully he's not, so I can give him a compliment and he won't hear it. But the bottom line is Joel's one of those guys that just got started doing implants a couple of years ago, and he's really taken no prisoners. He's doing a tremendous amount of implant work. He really is capitalizing on what's available in implant dentistry. So proud of him, and I hope he didn't hear that. All right, Angela Dorsey, she says your lectures are always interesting, and I'll be happy to learn anything about anything you have to share. Well, thanks, Angela. It's very nice. I will try and not disappoint you as the day goes on. And Angela's a really nice person, so I think that's a sincere comment, so thank you. All right, so let's talk about implant dentistry. In the last 26 years, I guess we can all agree that implant dentistry has changed dramatically. Products have evolved, and that process is not slowing down. They're continuing to evolve, and it's changing rapidly as we speak. Processes have changed with the technology advancements, and I think we're all well aware of that. CBCTs, CAD and CAM software, CAD design, CAM manufacturing. Again, it's pretty much dentistry today, but especially in the implant world and manufacturing world. 3D printing over the last couple of years has really dramatically changed. Went from a few people having 3D printers now to almost everybody having a 3D printer that you could potentially make surgical guides with and whatnot. So all those things are moving forward. And I always say to people, if you quote me, date me. And the reason I say that is what I did 10 years ago in practice, virtually a lot of those approaches are old news, and I just simply don't do them anymore. I can honestly say a lot of the things I did in dental school, we'd all say that. We don't take much of that and use it for very long. I think with implant dentistry, if you're 10 years in the past, you're probably doing things a lot differently than you are currently this year. The technology is just not slowing down. Having said that, there's still plenty of challenges that are still yet to be tackled in dentistry and also in implant dentistry. So with that as a start, recent innovations in implant dentistry, let's just talk about a few of them. This one's not terribly recent. It really was 2004 to 2006. 2004, the CTs hit the market, have dramatically changed diagnosis, treatment planning, surgical protocols because of the three-dimensional view. And virtual treatment planning software is really the software that takes the data from the CT machine and puts it into treatment planning software. So again, that's not a new, necessarily a breakthrough, but it's certainly one that had significant impact. And just real quickly for all of you, what does that bring to the table? It basically brings you that buccal lingual dimension, that three-dimensional view that we didn't have with pans and periapicals. And again, I won't go through this in detail, but I always think of a case when I'm doing a diagnosis or restoration, if this drill could be replaced by an implant, that would be awesome, because obviously the crown could be supported by the abutment underneath that crown. So it's really like building your case on a computer, knowing that it can be done or can't be done before you pick up the scalpel. So that's really one of the bigger innovative technologies in the last 20 years. So in a nutshell, what does that mean? If you know where the final restoration belongs, like you see in this picture here, you know where the buccal bone, the crest of the ridge, and the palatal bone, you then can go into software and decide which implant you want to put in, at what orientation, and does it give you what you want in that clinical case, or what limitations are there. I always say to people, if you understand just this one slide, this one image, you pretty much have a good handle on implant dentistry, because if you understand how to do this for a single tooth case, it isn't much more difficult to do a case that has 12, 14 implants. It's the same technology that we're looking at. All right, so again, just to summarize, I'm trying to bring it back to what I do in clinical practice and what we've evolved to here, and I'm going to try and show you that as we go through this presentation. If we look at two-dimensional approach of implant surgery versus three-dimensional, two-dimensional approach is still 85% of the market. So is it effective? And the answer is, well, of course it is. If 85 out of 100 implants are put in non-guided, freehand, whatever approach you want to call it, are done, obviously it's successful. Is it 100% successful? No, but neither is guided surgery 100% successful. So it's an approach that's been out there a long time. It's a successful approach. And again, I'll just run you through how that would go. Now, since I have a CT in my office, not everybody has one, but if you have one, even if you're going to do free-handed dentistry, there's a lot of data that you can get from the CT machine. You can't take that data to the surgical field other than what you can keep in your head. There is no device that you would use to move that data to the surgical field. But again, just having the three-dimensional x-ray before you do surgery, if you had that opportunity, gives you this information. So you can go in, even though you're not turning this into a surgical guide, you can go in, pick your implant system of choice, place it in the bony structure, put it on an abutment and a crown, and see if everything lines up the way it should line up. So this is kind of old news, but it's pretty effective news still in 2020. Again, this all started 2004 with the CT machine, 2006, I think, for the treatment planning software, but obviously changed dramatically how implant dentistry is done. So let's look at a potential implant case. I'll call this a CT-driven, non-guided surgical procedure. So what does that mean? We have a patient, we have a three-dimensional x-ray, we don't have a surgical guide, and how would I do this case in my office if I was doing it tomorrow? I'll just walk you through how that process goes. I'll be honest with guided surgery, there's a lot of costs and challenges and whatnot with guided surgery. They're less now than before because they're better, well-defined, thought out, integrated, those type of things have improved. But there's been real challenge with guided surgery. If nothing else, the cost of it, having the CT machine, having the treatment planning software, having this, all the tools that you need to do guided surgery, it wasn't a small hurdle to get over. So let's just assume that, and again, to be perfectly honest, until recently, I pretty much never did, almost always never did, that's poor grammar, but almost used guided surgery for a single implant case in my clinical practice very seldomly because the cost of it was not a good return on investment in my opinion. All right, so let's do a non-guided surgery. Lingual line incision on the maxillary arch, I always think is a good idea because when you reflect the flap off the ridge, you can see the lingual line angle on the lingual side and the buccal side, and your tissue is pretty much out of the way, held by your retractor on the facial. So the tissue reflection, and again, if you don't have a three-dimensional surgical guide, a tissue reflection is important. To do non-guided surgery through a biopsy punch, in my opinion, is pretty irresponsible. There's just too many unknowns. So again, in my practice, I'd use a lance burr to make a purchase point. So again, you're picking a point between the mesial and distal tooth and midpoint between buccal and lingual and trying to stay inside the bony walls. That's really what non-guided surgery is about. So there's your purchase point with a lance drill. It's just like a little spear, the lance drill. You'd follow that up generally with a pilot drill. In the pilot drill, I always say if you could go in 6 to 8 millimeters, enough to stabilize a parallel pin, you've done what you want to do with the pilot drill before you take your first x-ray. So your first x-ray then would get taken with a parallel pin. It would look something like this. And then you would verify your angulations. Your angulation is good. Buccal lingual you can't see on this x-ray, but at least you know you're going in the right direction if your x-ray looked like this. Now let's say it was too close to the root of an adjacent tooth. Well, that's what you want to find out before you get to a bigger drill, because you can redirect and correct that angulation. All right, so your final drill then would be determined by the CT if you looked at that initially. So we're just verifying there in that photograph that we're going to drill to the proper length. So if you're putting in a 10 millimeter implant, obviously you want to drill at least 10 millimeters. If you're going subcrestal, slightly more. Those are just the calculations that you would do manually if you weren't doing guided surgery. All right, so we verified in this osteotomy now that we drilled to the appropriate depth, and then we're going to place the implant with whatever approach you like to place it. I tend to place them with a motor-driven handpiece. All right, so you're driving the implant in. Wouldn't matter which implant system. I mean, this is, the process is the same. The implant's placed. Remove the transfer. There's your implant placement. Determine at that point whether it's at the right height or not. If you want to place it subcrestal with this implant, obviously you can. So we're going to drive that implant down to the right depth. Once the implant's placed, then you have two options. Your healing cap would be option one, where you would avoid a second stage surgery. You wouldn't have to come back and uncover the implant because the healing cap keeps that site open to the oral cavity. Tissue would be sutured around that healing cap. Option two, if the implant wasn't very stable, would be a cover screw that comes packaged with the implant, and then the cover screw then would be covered up by the tissue, and you come back later and do a second stage surgery. So nothing new here, pretty straightforward stuff, just a review of potentially what you can do or should be doing in clinical practice with non-guided surgery. So intraoperative x-rays, fantastic idea, keeps you out of trouble, keeps you going in the right direction while you're doing that type of surgery. So again, just as a review, now let's go to guided surgery. CT scan plus treatment planning software and a surgical guide. So now you've taken the CT scan and now you're going to use the surgical guide. Well, here's the standard protocol that's been around since 2006 basically. So step one is you're going to take a standard impression and digitize it, turn it into an STL file, or you're going to get an STL file from an intraoral scanner. So that's step number one. Step number two is you're going to scan the patient. At some point then you're going to merge these two STL files together into treatment planning software. So you're going to take this STL file, this DICOM file, convert it into a the treatment planning software, and you're going to do a treatment plan. Picking the implant, the number of implants, whatever the case may be, and then you're going to turn that into a surgical guide and do guided surgery. So it's about a 5-step process with some variability depending on the implant software that you're using, treatment planning software. So real quickly, this would be a case that potentially you'd want to use a surgical guide, not with this situation here. This was an ortho case that was referred to me for implant. Well, you can take a 2-dimensional x-ray and find out that that's just not a case that's going to go forward, just not physically not enough room for an implant. So back to the orthodontist, open up the space. Patient was, I think, 19 years old, in ortho for 4 years. So if you put an implant in this case, I think we could all agree that you're going to violate every rule that's in the literature. You're not going to have enough space between the implant and the adjacent tooth. All those things are going to jump out at you. But again, are you going to put somebody through ortho and orthodontist for 4 years and then tell them, whoops, sorry, we can't do the implant, but thanks for playing? So obviously, as a clinician, you're going to help out here and you're going to do what you can do. So it's going to take a small diameter implant, but you can also see in that situation there is no room for error. So this would be an ideal case, even if it's a single implant case, even years ago, which this was, is to do guided surgery. Because you don't want to hit the roots of the adjacent teeth. You want to idealize the placement position as best you can. So that's the concept of guided surgery, and guided surgery works. We've proven that. So here would be your surgical guide, biopsy punch to remove the tissue, pilot drill to make your initial purchase, parallel pin to verify. You don't trust these guides, but verify, and move the case forward from start to finish. So again, pretty straightforward stuff, not new, but that's what's out there still today, and it works really quite well. So you can see here we're just deciding how deep to drive the implant in, and when we're satisfied with the implant depth, then your next step is either temporize or in some fashion or just move forward. So there's your final x-ray. And your x-ray shows you got pretty good ideal placement. Place subcrestal again, because in my cases, if I can go subcrestal, especially in the aesthetic zone, it gives me just a deeper emergence profile, ability to build the emergence profile the way I want to build it. All right, so that's the concept of guided surgery. Okay, what are the costs associated with that? Well, these are pretty fundamental costs that have been out there for a long time, but when it's all said and done, you could have $300-400 because you're going to have a cost for the guide, cost for the CT, cost for the treatment plan if you're not doing it yourself, and then a cost for the production of the surgical guide itself. So all those costs have been out there for quite some time. The costs that I routinely paid for cases, treatment planning wise, through the company that I actually owned part of for a while. I don't anymore, but these were typical costs that were associated with a single implant site, $385. So again, pretty significant input of cost for a single implant case. If you get up to the 4 implant site case, $736 versus the cost of placing and restoring 4 implants, not a big deal. So guided surgery in the past has really been freehand a lot of the single cases, do guided surgery on your multiple unit cases, and really driven by the learning curve and the cost of doing business. But that's what was out there. That's what was apparently available. So for many years now, the cost of guided surgery has been significant, but we can say with certainty, done well, the technology absolutely works. So control is possible. What are the challenges with guided surgery? We kind of covered them already. Time and money. It's always time and money. Equipment needed. Obviously, CT machine, all the things that we talked about, digital scanners, all those things are needed for that. Accuracy of the equipment and surgical guides has been a bit of a challenge. Human error factors are involved as well. Cost of the practice and the patient. Learning curve to use the technology. So what is the problem with guided surgery? This is a millennial research, so it's pretty accurate research on the dental industry and what's going on. 2014, there were less than, 15% of surgical cases that were done with guided surgery. In 2020, they predicted about 13%, or less than 12%, 11%, I guess, which is pretty accurate. And they think by next year we'll be up around 13% of cases, 13 to 15% doing guided surgery. So again, pretty accurate, and it explains why guided surgery has been challenging. So let's move now to Implant Dentistry 2020. In my clinical office today, we identified that the biggest resistance to guided surgery for a single case is cost. So let's talk about how to potentially reduce some of that cost. Now, let's just walk you through this slide, and I'll go over it in more detail. I'll actually show you a video of the case. But in my office, now again, these are not commercially available yet because we're working on software integration. But in my office, you could routinely take one of these surgical kits that has different attachments in there, turn it into a surgical guide, and do the surgery without sending it out to a laboratory. So how does that work? You potentially would have these components that you see on the left. I'll call this the tray. Let's call it impression tray. And above the impression tray is another attachment that you put on when you take the impression. And then the little yellow markers here that you see in this component here is the radiographic markers. So the concept is we're going to take this packaged plastic injection molded pieces and use it as an impression tray and then eventually turn it into a surgical guide. All right, so if you look at that, once you've used this, put impression material in it, scanned the patient in your CT scan, inserted that data into a treatment planning software, you then, with a 3D printer, could print the insert that you would use to do a surgical guide for a single tooth. All right, so that would be your first appointment over here. Your second appointment is surgery. And during your second appointment, we have capabilities now of using some different drills, and we'll just say they generate a lot less heat, so a lot less bone damage during surgery. Because you generate a lot less bone damage during surgery, the reparative process, the integration process is much shorter. So in your second appointment here, you're doing surgery. It's not sequential drilling. It's basically the software tells you how deep to drill. You're going to take a drill, your final drill, and take it to depth without any previous drills. So again, guided surgery, you know where you're going. You're just going to take it to full depth. Once you get to full depth, you screw with the implant in. These are multiple use drills, but obviously they're different drills. They're just much sharper. They're more like a weapon than a drill if you're used to standard drills. All right, so they remove bone quicker. They're more efficient in what they do. It's not sequential drilling. So literally in 5-6 seconds, you do your osteotomy potentially, and you screw your implant in. Because you've done guided surgery in a single case like this, oftentimes in my practice, I'll take my intraoral scanner, scan the patient the same day with the scan body, and have the final restoration made. So all this happens in the first appointment, the second appointment, do your final scan. If you got a stable implant, you think you want to restore it quickly. So in 6 weeks now, because we haven't damaged the bone by doing the osteotomy and whatnot, most of these cases now that I do in bone that's healed is a 6-week integration time rather than 4 to 6 months. So dramatically different than what I did even a year ago in clinical practice. All right, I think Dr. Klum asked about the ISQ device. This is an ISQ, implant stability quotient is what it stands for. The ISQ, so at 6 weeks, let's say we want to restore the case at 6 weeks, it would be a good idea to take your implant stability quotient device, a radio frequency device, and test the stability of the implant. It doesn't test integration, it simply tests stability. So if you're above 60, you're pretty safe to restore the implant. So at 75, we're going to go ahead and restore the implant. So the scan was taken during the surgical appointment. We've tested it at 6 weeks. We're ready to restore. We're going to put in the patient-specific abutment and crown. It was pre-made and on the shelf for that 6-week period. All right, so this is a pretty typical restoration. It's a multi-unit attachment, basically. It's a hybrid attachment. It has a titanium abutment, a zirconia core, and a zirconia crown. So pretty typical restoration in the practice. So at 6 weeks, it gets inserted into the implant, final crown cemented, final x-rays taken. So again, dramatically different than what I did in practice even a year ago. So let's watch the video and I'll kind of walk you through the whole process as we go through it. So if you're looking at that particular case, this would be your patient with a missing tooth. Looks like tooth number 4. That's a pre-op x-ray that was taken prior to the extraction. The site was healed, however. So what you're looking at there is a different size blades that would go in between the tooth that's missing. So you're just trying to find a blade that fits that space and it's not too loose or too tight. So that's a little bit bigger blade there. So we'll try it in that space. And the reason the blade's there, because when you put impression material in there, and then you can't see the space anymore, you want to use that blade to put that in the center of the missing tooth space. So that's what you're looking at. All right, so once you've done that, then you snap that component part to the tray or the frame, whatever you want to call it. Not necessary to put adhesive in there necessarily, but we always do. It does hold the impression material because it's a fairly short tray, helps hold the impression material in place. Now again, what impression material can you use here? Pretty much anything. I like Impergum. That's what we use for polyvinyl, polyether type impressions, crown and bridge impressions. We've tried bite material, which is more rigid, but almost too rigid. So I'm back now to using Impergum impression material. But different materials potentially would work, depending on what your preferences are. My daughter's working with me now. Those are her hands, not mine, so my hands haven't shrunken. All right, so there is basically the impression, which will get turned into a surgical guide. So you let that set up, whatever time it takes to set it up, take it out, remove the initial cap, like so, put on the snap cap, the scanning cap with the radiographic markers, those little white radiographic markers that you can see. I think in this case there's 7 of them on that appliance. Snap it back in place, make sure it's good and stable, in the right position. You're ready for the next step, which is the CT. Did that stop? All right, I think because we're sending this out, let me get out of PowerPoint. I did a webinar the other day and I had the same trouble, so let me just show you the video directly. Let's get back up to where we were. All right, so this is the appliance in the mouth, CT scan with the radiographic marker on the appliance. Now the patient's ready to go home. So that's all done basically in the first appointment. Import that data into treatment planning software, and then you would do a surgical plan, export that to a 3D printer. Could be in your office or at the laboratory, however you choose to do it. But you would then print that insert, and then put the metal tube that guides the one drill into the insert, which is what you're seeing there. So this is, again, just cutting out the impression material where that insert needs to be inserted. Probably the most dangerous part of the whole thing. And then once you've removed that impression material, you simply then just insert the insert into that frame. So again, while you're watching this, if you guys have any questions that you're thinking of, you can certainly type them in. We'll cover them if we need them, or you can turn your mics on when we're done. We'll answer them live. So here's your surgical guide now ready for surgery. So this is a bent perio probe. A straight one would make more sense. But again, we're looking now to just mark the tissue so we can use the biopsy punch to cut the tissue out of the way. But as you watch this, and again, for a $45 guide plus whatever the insert would take you to print, it's a significantly quicker and less expensive approach. We're just removing the tissue, and then we'll reinsert the surgical guide and do our osteotomy. We good? Okay. All right, so here comes now your surgical guide. Just want to verify that it's seated properly, obviously. And you're ready then to do your osteotomy. So again, could you have inserts in sequential drilling here? You sure could. Or you could use this approach with the lucid drills and just take it to depth. So it's literally seconds. Measure your depth and make sure that your software will tell you how far to drill from the top of the metal tube to the bottom of the implant site or osteotomy. You just want to verify that you drill deep enough. So this happens to be the new Implant One series. Can't read it. Series, I'll tell you in a minute. Series 400 because it's purple. So the Series 400 implant is at least a 4.0 or bigger. Comes packaged similar to the way the initial implants were packaged onto the driver. And we're just going to drive this implant in with the motor-driven handpiece. So here is our implant placement. And then once we get the implant close to the tissue level, if it torques out, take off the transfer. and then evaluate the depth of the implant. If you're at the right depth, great. Then do whatever you're going to do next, whether it be an impression or a healing cap or whatever you decide is the right approach for that particular case. This is the driver out of the surgical kit. Surgical kits are much smaller now, and we'll show you that a little bit. But now we're just going to use the hardened drivers just to drive the implant in a bit further. And then check your depth. You certainly could take an intraoperative x-ray at this point and see if you're at the depth you want to be or whether you're at the bottom of the osteotomy or not. So those things haven't changed. Those are just typical surgical things that you would do. This would be option one. This would be a cover screw. If you had poor stability of the implant, put the cover screw on, one miracle at a time, let the body heal and come back later and do the next steps. If you have good primary stability, you certainly could use a healing cap, which is what I think I show you here next. So that would require what we just saw, a second stage surgery. Here is your healing cap. If you want to avoid the second stage surgery, that would go on. If your decision today was to take the final scan, you certainly could do that. So you have all those options, obviously, that are still available to you. All right, x-ray to verify that the implant's placed correctly in a two-dimensional view. And there's your final prosthesis or final implant placement. Obviously, when you go subcrestal, you have to be aware that subcrestal placement and putting on additional components that they fully seat and don't run into bone. So at the integration check, you take off your healing cap. If you didn't take your final scan initially, this would be the time to take it. So this is the ISQ multi-peg, and the multi-peg is just screwed in to check for stability. People say integration. It's not integration. It's how stable is the implant. So remember I said before, if it's 60 or above, we're ready to restore. So at 75, we're confident that we have pretty good stability and integration of the implant. So this is a digital scan body that matches the system. So we're going to put that into the implant, make sure it's in the hex, and tighten it down. Now you can imagine if this is a single case or you had 4 implants, it's the same process. It's just a matter of getting the scan body fully seated and taking the final digital scan. If one thing we've done, I think, extremely well with this new implant system is we're as digitally driven as anybody and better than almost anybody. Have all the digital components that you potentially would need to run a digital practice. So this happens to be CareStream. It's a system we have in the office, and we like it. It seems to work well for us, but the digital scan could be taken really by any scanner. Pick a shade. Obviously, you guys are well aware of how this process works. Final restoration is made. We showed you this in the previous slides. There's your digital analog, digital model, digital restorations. So we're going to remove the healing cap. This was 6 weeks after we placed. Abutment and crown will go in place. Torque it down to the proper torque, depending on which implant system you're using. I use basically plumber's tape to cover up the screw. So whatever you guys use, I'm sure is just as good, but that seems to work well for me. And then cement the final crown. So that's basically the whole process from start to finish. Could be done in as few as 3 appointments in your final restoration. Final placement position with x-rays verifying that everything is fully seated. All right, give me just 1 second to go back to the presentation. All right, so that's it's showing double. Oh, is it? Okay, hold on. No, that wasn't quite right. Good? All right. So the next case, a very similar case. It's another 6 weeks integration. So implants placed using the same technique. Final restoration ready at 6 weeks. So we took impressions on this one the day of surgery. And then again, we're at 80 at 6 weeks. So 80 again, let me just cover that quickly again. you could be at 80 when the day you put the implant in a dense bone profile. Understand that's not integrated the day you put it in. It's just simply stable. If you go through that integration phase, that 80 is going to go down to 70, 60, 50, and then go back up to 80 again. So if you're measuring the day you place it, that just gives you an indication of initial stability. If you're measuring it some 4, 5, 6 weeks later, you're getting the stability that's associated with integration. So understand the difference of those numbers. All right, so again, final restoration, patient-specific abutment. This one happens to be made out of all titanium, custom abutment, and a zirconia crown over the top of it. So that would be a typical approach to a case like this. This is the new implant system too. It's a more aggressively threaded implant. We'll talk about that in a little more detail in a minute. All right, so with that concept, what we're doing here at Implant Logistics to help our customers, and this, again, it's just for the people that are using us because we're not trying to be a laboratory, but we're trying to help our customers get started and do well. So fixed pricing for our customers is simply this. If you want a patient-specific abutment and a crown made at this laboratory, it's a $300 cost for the whole thing. If you want an implant thrown on top of that, it's another $195 for the implant. So it's a tooth in a box kind of a concept. And it will be available when we get up and running again, when all of us get back in practice. So that's fixed pricing if you're doing a digital flow and you want some laboratory support going through this. So our concept is, because our system is a standalone system and not every laboratory is familiar with it, we're trying to use this process to educate the doctors on how the system works and then potentially educate the doctors' laboratories on how the system potentially works. So make the experience a little more foolproof. You know, if guided surgery is on top of that, we are working on doing some guided surgery here as well. We're not set up for it yet, but we're working on it. And would think in a couple months we'll help doctors with the guided surgery part of it, treatment planning as well. So that's what we're doing again here at Implant Logistics. How can we do that now? I have a technician that works in the laboratory. This is the machine that we've had for a few years. You can see it has one puck in here, and one puck can make about 20 crowns. But every time you change the color of the crown or something, this puck has to come out and a new one goes in. Well, I just purchased recently a machine that has 36 pucks in it, so we could make a whole heck of a lot of crowns in a hurry, where this took us a long time. So we're trying to ramp up to provide a better service for the Implant Logistics customers. All right, does that make sense? Let's move on. Next topic, let's talk about drill technology in these lucid drills, since I showed them to you. These are available now, and these drills are just drills, and I'm not going to spend much time on it, but these drills, they're pretty well researched. They're German technology, basically, and German-made drills, but the drills just produce a lot less heat during the osteotomy phase, whether you do sequential drilling or one drill at a time. The real critical number, according to the research, is 47 degrees centigrade. At 47 degrees centigrade, you start to kill bone cells. And the higher the temperature, the more bone cells you kill. The higher the temperature and the longer you stay connected to the bone, heating up the bone, the more bone cells you kill. And the longer it takes for those cells to regenerate and the implant to integrate. That's in a nutshell what all the studies are looking at. I used to think if you had a pilot drill that wasn't very sharp, no big deal. The studies out there show that if you have a pilot drill and you're in there for very long at all, you can generate some tremendous heat, and the heat will spread out about 20 millimeters from the initial pilot drill hole. That was news to me, but pretty well researched. They're actually showing a lot of implant cases that have endo on adjacent teeth because they burn the bone around the adjacent tooth. So pretty dramatic information I was just totally clueless of. But once I started looking at it and realized the process of heat generation and bone damage, it kind of woke me up. So all in one protocol. It's a totally different drill. It's pretty different on the end. It's a real step drill. You could use one drill, you could use two drills versus a whole series of drills for this particular system where they go through sequential drilling, which is what we all did for many years. And it works. It just requires more integration time. That's it. So again, the average drilling time, if you use sequential drilling, could be as many as 10 minutes, 8 to 10 minutes. And the average time for these drills when they were studying different clinicians is about 12 seconds. So it's pretty fast. And again, the effects of the implant site preparation, more heat, more damage. The red cells are completely dead. The damaged cells are the pink cells that you see in here. Again, it's in the research. I'm not going to bore you with it. But the one drill protocol, significantly lower temperatures, and for me, significantly faster integration time, and that's really what I liked about the whole process. All right, so again, pretty well documented. It's been in the literature for a long time. This is not a new study. It was way back in 2005. I just didn't happen to read it. But when you do an implant osteotomy, you have secondary new bone that's developing from the osteotomy, and you have the old bone holding the implant in that's going away, and there is a stability dip in the integration somewhere in the 3 to 4 week range. So the stability dip using standard implants, if you understand that's graft, or standard drills, is a pretty significant stability decrease in the 3rd and 4th week. If you use the more current drills, the stability dip is still there, so that's the timeline on a standard drill versus the stability dip on a less invasive, less damaging drill. So pretty simple stuff when you get right down to it. Your normal stability dip, so you go from 100% stability the day you put the implant in, way down to about 25%. So that's when you would potentially lose your implants, especially if you're trying to do immediate load. Where you get here is you still get a stability dip at about 3 or 4 weeks, but the stability dip is 75% of initial stability versus 25%. So dramatically different. If you want to do immediate load implant placement, obviously a much safer approach by avoiding that dramatic stability loss during the healing process. So again, in the research, pretty easy to find. So those drills are available now. They're called lucid drills. They're multiple use drills, but again, like any other drill, they have to stay sharp if they're going to do what they need to do, so that you can't use them forever. 20 osteotomies or so, I think, would be a good number, like any standard drill, to replace them. So that's available, that's new, that's what's out there. That to me is really dramatic change in the last year in my practice. All right, so let's talk now about just the Implant One, the new series 3, 4, and 500. They're color coded, so which is really kind of nice. That's one of the advantages now, because if you're using a different platform diameter, obviously a smaller platform is not as strong an implant as the largest platform, but the implants themselves, the abutments and whatnot, are color coded. There is 2 versions of this implant. You have the very aggressively threaded implant for poor bone stability, immediate extractions. Doctors seem to like it for that, and the more standard thread design with a micro thread up on top. All right, so I'm pretty proud of the improvements here. I think I use probably more of this implant than this one, just because I'm used to the older version of the implants, and these are even more aggressively threaded than the Series 1 and 200 that we previously had. So I think you could use both almost independently and not use, or you could use either one independently, not use both. But if you're in a real dense bone profile, these actually, counterintuitively, the aggressive thread ones screw in seemingly simpler, easier in any bone than the less aggressively threaded one, I think, just because the threads are so aggressive. So a little counterintuitive, but that's the way it seems to work. But they come in 8, 10, and 12, 14 millimeters. So what are the features and benefits? It's not a knockoff system. I tell everybody you need to understand that. There's no Nobel or Straumann or 3i or Zimmer part that's going to fit on these implants. It's a totally standalone system. It's not compatible with any other system, in other words. So it's not a 40-year-old implant repackaged. It's kind of an innovative implant in my mind that tries to solve the 3 biggest challenges that we talked about initially. So the Implant One features and benefits: it is a standalone system. It is a system that provides solutions to any clinical situation in my mind. It's a superior system to many antiquated systems on the market today because it can be placed subcrestal. It's a value-added, cost-effective implant option for clinicians and dental technicians, so it's not an expensive implant in comparison. I already said it's a robust system. I think it can be used in any situation, and it's more digitally driven, I think, than any system out there. We have worked hard at that, and I'm proud of that process too. So the system's designed to be placed at crest or below, or if desired below crest. Those things are out there. So the standard implants are like so. I'm not going to spend time going through them, but if you go to the website, I've just pulled these images out of the catalog on the website. You can look at these for more information. So it's got a variety of standard implants from 3.5 to 5.5 and aggressively threaded implants from 4.1 to 6.5. So there's a pretty robust number of implants. Restorative options. Like any other system, it has the tie-base abutments for the zirconia hybrids. It has the conical abutments, which is really, we're going to rename that. It's really the MUA attachments, the multi-unit abutments that you'd use for screw-retained anything. And then it has the standard abutments that have straight and angled, which virtually aren't used too much anymore, but they're available if doctors want to use them. The custom abutments. We showed you a patient-specific custom abutment made out of a blank, and that's what these blanks are. Straight abutments are out there. Temporary abutments that you can remove easily are out there. So the wide post abutments and the solid abutments. So again, lots of opportunity to get what you need. For the denture attachment, there's a ball attachment similar to what we had in Series 1 and 2. And there's their denture retaining abutments, which are basically locator abutments, are also available in this system. Healing caps come in a variety of tissue heights, widths, and whatnot. So again, all in the catalog. I won't waste time with it. When it comes to impressions, you certainly can take a standard impression like we did with Series 1 and 2, similar standard impression posts. Open tray impressions are obviously available as well. The analog, we made a change with the analog. This analog now is the only analog we have. It fits standard impressions, it fits open and closed tray impressions, and it also fits the digital impression analog. So all those things have been simplified in a sense. So here's the digital impression option, and we put a lot of work into this, trying to develop a digital analog that's easily picked up by the scan bodies. Or not by the scan bodies, by the scanners. So these scan bodies are pretty easy and pretty accurate, and they give you a good scan if you're going the digital approach. Patient-specific abutments that I talked about and showed you earlier, that would be a blank that would get milled down depending on the implant connection to the patient-specific all-titanium abutment that you were looking for. So again, laboratories would have these available. So there's your patient-specific abutment. You saw that slide already. Our drill kits and surgical kits are much smaller than the previous one. They're easier to sterilize, easier to maintain, many less drills than when the original surgical kit. With this new surgical kit, I think there are 1, 2, 3, 4, 5 drills, pilot drill, and 1, 2, 3, 4, 5 other drills to put all the implants in. If you're using sequential drilling, if you're using the Lucid drill, there's a surgical kit for that one as well. So a simpler, I think, surgical event than it used to be, less drills, less options. So to do any implant, you would basically need the drill kit and the surgical kit to put in any one of the implants that you saw previously. Restorative kits made for this system. We never had one for the last one, but again, if you're restoring a case, you used to always have to take out the surgical kit, which was kind of a hassle. Now we have a specific restorative kit with 2 torque wrenches for the 2 torque values on the different platforms that we have to offer. All right, so subcrestal placement, I think you all know I'm a component of that. It gives you a lot of latitude in clinical practice. So the biggest advantage, I think, of this type of implant system is you can do things with this system you just simply couldn't do with other systems that I used for the first 10, 15 years of my practice. So even if buccal bone's missing, if you can stabilize an implant and you can place it below the buccal plate as you see here in this case, if you could do that, potentially then we can do some grafting in here and we can close this up, and instead of doing it in multiple surgical appointments, we're going to do the whole thing in one appointment. It's pretty common that you run into some buccal bone loss or all the buccal bone loss extracting some of these anterior teeth. So it's pretty rare now that if I can stabilize the implant, orient it correctly, and I can get it behind the buccal plate, I'm going to do all that now today in one appointment. It's very predictable with the fairly predictable grafting techniques. So graft would go on top of that, a barrier to close it up and give it the appropriate time for that case to heal. Pretty typical in practice today. If you use implants that go subcrestal, there is a unique challenge of tissue development. If you're going to start your emergence profile at the top of the implant, always remember if you're subcrestal, you've got to bring it straight up before you start to build the emergence profile. It's an advantage, but it's also a way to get yourself in trouble if the laboratory doesn't understand that the implant's placed subcrestal. So this information, when you're ready to restore a case, needs to be transmitted or transferred to the laboratory so they understand subcrestal placement and emergence profile that needs to be handled in those cases. When ankylos first hit the North American market, that's the biggest bath they took, is they didn't explain that well. I'm not saying it's ankylos's fault, but the laboratories didn't understand that. A lot of remakes were made because there were a lot of bone collisions when they were trying to restore that case. But that's not new to the market now. It's been around since about 2006 as well. All right, so subcrestal placement possible options. You look at a digital scan here. This would be an implant placed at crest or slightly below. This is the scan body, the digital scan body. It's a flat on a flat, so you can visibly see here that this implant scan body is not fully seated. So we've changed that. It's a flat on a flat now, and if you get it profiled correctly, get the impression post in there, whether it's a scan body or a standard impression post, now you're ready to take your impression. So I think that's an improvement as well. So this would be a more aggressively threaded implant in the maxillary arch, placed significantly subcrestal again, scan body fully seated after it's been profiled, and here is your restoration. All right, so your bone profiling kit looks like this. It's similar to the last, no, it isn't similar, it's a new kit, I guess, but it has all 5 different platforms for the 5 different Series 1 and 2, which I don't usually even use anymore. I've pretty much converted everything to 3, 4, and 5 because of all the improvements we've made to the new system. So a bone profiler would look something like this. If you're using a subcrestal implant, you're going to have to get to the cover screw to take it off. Let's assume this implant was placed subcrestal. So we've biopsy punch, got into the cover screw to take it off. Once the cover screw's off, we're going to put on a guide pin, and then you're going to profile the tissue and bone out of the way with that profiler. So those profilers come in 3 different sizes, but you can see again, guide pin in place. We profiled, now we have the impression post, and it's fully seated. It's a flat on a flat, and all accomplished by that bone profiler. So this is what the bone profiler would look like in an animated version. All right, so that's a bone profile and how it would work. The other improvement I think we've made is the old impression post. We're not a flat on a flat, so me and everybody else included had a little trouble of deciding whether this thing was fully seated when we took the x-ray, so that was always a bit of a wild card. And now again, with the new impression post, we take them a flat on a flat, so that question would potentially go away. All right, so there would be, again, your scan body. This is placed quite a bit subcrestal, as you can see. In this case here, put on the digital scan body, and the digital scan body was actually at the tissue level, so there wasn't much to scan. So you have a way out. You can always go back to your standard impression post, take a standard impression in a situation like this where you've got the implant pretty deep, and then restore the case. So just some of the things that potentially you could run into doing your cases. Another thing that we're pretty proud of, we've got a design built into this that you all know that have used Implant One or other tapered implant systems. Once the abutment goes in place, it is darn hard to get it off, whether it be the same day or a week or a year later. This implant system now has an abutment removal tool. So if you were 5 years down the road and for some reason had to take the abutment out, if you got the crown off, you take the screw out, and once the screw's out, you would insert this removal tool into your abutment and remove it. So that concept is there as well. So that's a big improvement, I think. I don't know if there probably are other tapered systems out there that have this, but I'm not aware of them. All right, coming soon, we actually have kits made, but not for sale yet. These are drills with stops on them. So if you're doing freehand surgery, non-guided surgery in this case, and you want to drill a specific depth, we're putting together a kit that has stops on it. So in this case here, I can't read the numbers, but in this case here, it looks like there's numbers on the side here. If you want to drill to 14, this is your stop. If you want to drill to 8 millimeters, that's your stop. So physical stops to keep you from drilling too deeply in the bone, which is what some doctors were looking for as well. All right, next topic, cement retained versus screw retained. There was a question from, I don't remember which doctor it was, about cement retained versus screw retained, and we'll kind of bring in the all-on X approach to this as well. So if you're doing a screw retained anything with anybody's system, you're basically using a MUA or a multi-unit attachment. So in our system, there's straight multi-unit attachments, and there's 17 and 35 degree multi-unit attachments. So again, you can correct a lot of angulation issues, obviously, with a case that's going to be a full arch with things tied together. All right, so the multi-unit abutment would look something like this in software. So if you could envision this analog that's here, is actually the implant in the mouth, but on a model it's the analog, and the analog has a MUA attachment attached to it. And this MUA attachment then, because it's either straight or angled, could be rotated in a proper position to align these implants up as best you can. And again, you can have an awful lot of correction if you can angulate these up to 15, 20, 25, 30 degrees. So there's your multi-unit attachments. This would be a screw retained approach to a bar, to a zirconia hybrid, to a denture attachment. If you wanted a removable denture, all those things would use this same attachment to move forward. On these multi-unit attachments, there is another scan body. That's actually a second scan body with the same orientation or the same design as the implant level of impression. So what you're seeing is here, you've got the analog up here that we showed you. You've got the multi-unit attachment onto the analog. and now you're not taking an abutment level impression. In this case, you're taking a, in this case, you're taking an abutment level impression, whereas before you would be taking an implant level impression. So it's a different way, more accurate way of moving through all the attachments to fabricate your bar or whatnot, whatever you're going to do to make your final restoration. And these little caps that you see here are the caps that go inside the superstructure that you're going to screw together to hold it down in place. All right, so when you're all said and done in the software, it would look something like this. You've got your superstructure, you've got your channels, angled screw channels, we're working on those as well, that you would be able to go in and, even in severe angulation cases, correct it with this type of approach. So that is your screw retained prosthesis. I personally don't like the idea of screwing something in and having to take it out every 6 months. So for me, it's real easy. If I'm going to use zirconia, it's going to be screwed in the mouth or cemented in the mouth and not coming back out unless I have to for some prior reason. I'm not going to take them out every 6 months. It's too much of a pain in the backside. If there's plastic involved, it is going to be a screw retained. It won't be a screw retained anything. For plastic, to me, it's something the patient takes in and out. But there are a lot of plastic denture type appliances with a metal substructure that are screwed in the mouth. I just don't like the idea personally of having something that porous screwed into the mouth. So just a different philosophy of how things are moved forward. All right, so let's look at a particular case. If this was an all-on X case, 3, 4, 5, 6, 7, whatever, just to show you the capabilities and the variabilities that are out there if you're trying to do full arch cases. This is a case Patrick and I just did recently. So this is an 82, I think 83-year-old gentleman that his teeth were pretty well shot. So these are the final restorations that you're looking at with multiple implants, as you can see. But this is a cement retained prosthesis. It could be cement retained, it could be screw retained. It's really up to the doctor how they want to move this thing forward. But this guy's 83 years old. I don't want to take his case in and out, and we made him a cement retained prosthesis. But let me just walk you through the process. You might look at this and say, well, why did you put 3, 4, 5, 6, 7 implants in the upper arch and 5 implants in the lower arch with 2 in the back and 1 in front? Because this doesn't make a lot of sense. Ideally, you go 1 here, 1 here, 1 in the middle, and maybe separate these. Let me just walk you through why we did that. So again, 83-year-old patient, this is what he's walking around with. So these are his existing teeth. Not the healthiest guy in the world either at 83, but doing all right. So what we decided to do for him, we have a vertical dimension that he's worked with for 83 years, or at least since he had his permanent teeth. So we decided that we wanted to try and keep him in his temporaries because he didn't want to wear a denture of any kind if he could help it. He was trying to avoid that. He has a partial down here, as you can see. But he had a lot of trouble with an upper partial and just never wore it. So those are the kind of things I hear. I say, man, how can I treat this case without putting him into a denture because he's going to have a healing time that he's going to absolutely hate. And I don't believe in taking a lot of vertical bone away to get implants stable so I can load them the same way. It's just not my approach to dentistry. So what we did is we decided to look at what we had to work with. So we took an x-ray and we went through this like you would with any CT x-ray and say, where can I put some implants, keep the teeth that he has, and then restore this case down the road without putting him into a temporary something. So that's how we approached it. So if you look at the plan, basically what in the lower arch what we did is we put implants back here where he was missing teeth, and then we put 1 implant right up in front. And ideally you'd have another implant or these braced, as I said before. You can also look not ideal. These are his adjacent teeth, and you can see we're way down at the apex of the adjacent teeth to put the center implant in. So it's not the best site for an implant, but again, I'll just be honest with you. When on an 83-year-old, I'm okay with it. If it was 20 years old, if this patient was 20 years old, I might look at it a little bit differently. But we're giving him what he wants without making it any more difficult for him than we can. So that was the plan on the lower. And again, you're the doctor. You could make 5, 6, 7 other plans. They'd all be fine. But this just happens to be the plan that I put together. And on the upper arch, we did kind of the same thing. We planned 6 implants on the upper arch, 1, 2, 3, 4, 5, 6, where the teeth are missing. And then we figured we'd attach that after he heals up. But you can see he's got abscess teeth and other things that are in place right now that we'll deal with once we get the teeth out. All right, so that's the upper and lower plan. If you count the implants, I said we're putting 6 in. We put 7 in here because during the surgical part of this phase, one of these implants, I don't remember which one, I wasn't so sure it was going to make it. So because, and if I do this all the time, if you're putting in 6 implants, you've got a pretty good fee coming here. If there's a reason to put an additional implant in, I just go ahead and do it because I don't want to slow the case down because I didn't get one of the how many implants integrated on anybody for that matter, but especially somebody that doesn't have great regenerative potential anymore. So we put in those number of implants and we put it in his partials and let him wear those for, I think, better part of 6 months. At 6 months, we brought him back, we uncovered the implants, took final impressions, and did the bite transfer and sent this to Patrick, and Patrick made the final restorations prior to the extractions. So the final restorations, patient-specific abutments were made for each one of them on the model, placed in the mouth, and we extracted the teeth the same day. So again, we didn't cement these permanently. You can see it's temporarily cemented because we know that this area and this area is going to shrink up. As things shrink up, we might get spaces underneath the appliance. So obviously, we want to be able to pull these back out. Now, if you made a screw retain appliance, it would do the same thing, but this was cemented, or potentially was temporarily cemented. So we're going to give this another 6 months, 4 months, 5 months, whatever to heal, and then we'll pull these things off. Patrick will add more porcelain where needed to tighten up the spaces if those spaces open up. And it's amazing, those spaces open up sometimes, and sometimes they don't. But again, at 4, 5, 6 months, we're going to pull them off. If we have to modify it, it's an oven bake, all those kind of things. It takes some time. It's a day process. But again, we're only going with one restoration top and bottom that's modified, so we skip all the temporary phase that we initially would have to go through. So it's just an approach. I'm not saying it's a perfect approach, but it worked in this case. All right, so almost done. This is the last innovation I'm going to talk about, and then we'll take some questions and whatnot. There's some out there. This one probably has me more excited than anything I've done in a few years because I truly, before I get started, I think it could change how dentistry is done, not just in implants, but in a lot of the things that we do, dentures and everything else. So it's they're called radiographic alignment markers, and it will be coming soon, but it is different. And I think we've Patrick, the technician that works for me, it's mostly his brain trust. He came up with the concept, and we've been working through it together to try and make it a reality. So what's the most difficult, before we get into that, most difficult unpredictable step in a reconstructive case? How do you go from teeth to no teeth to back to teeth again in the occlusal relationship that you're really looking for? So those are the things I would say that have been the most challenging for me and anybody else doing full mouth rehabs when they're doing them for the last however many years. So let's look at a reconstructive case. If you were doing a full mouth reconstruction on this case, whether there's teeth or no teeth or some teeth, if your bite relationship that you're trying to accomplish is this bite relationship, how do you fill this space and how do you maintain when you start changing the teeth with preps or you start orthodontically moving teeth, how do you verify and justify that this is where you want to go? Now you might have an orthotic in there that holds this space. So I'm just trying to say, if this is the restorative space we're going for, how do we get there routinely, predictably, and make as few mistakes as we can? So it's a bite transfer technique using an articulator. At some point, this was in the mouth, and now it's on an articulator. So bite transfer technique using an articulator, that's how it's always been done. So if you're looking at a full arch case, for example, up and lower, it looks something like this. What do? Wax rims, mark the nose, mark the midline, mark the smile line, all those kinds of things, and anything else that you dream up to try and transfer that bite position to an articulator to and as you're prepping teeth. Not going to go through all of it, but you get the idea. All these things happen. Wax rims, bite transfers during prepping, remounting, smile line, all those things are involved. All right, so it's a lot of laboratory work too. And when you have something this complicated, the clinician that's doing the work has to be pretty accurate at what he does, and the laboratory technician has to duplicate that accuracy, or you got a challenging case when you're all said and done. So that's how normally those cases would go. So if you're looking at this case, you went from that orthotic to that final position was done a certain way. It was done on an articulator with the bite transfers, with all those things that we always had to do to transfer this case. Well, let's look at the next patient. Same thing. When this guy smiles, he shows no teeth. We want to restore him in temporaries with that and then take that into final restoration. So that's where we started. That's his position that we're trying to duplicate. So we went from really short teeth to a lot longer teeth. We don't have to reduce the height of these teeth. We want to add to them. So again, how do you routinely transfer that? You can see how you do it. Bite transfers and articulators. I'm getting to a point here shortly, but there's a lot of work here. This is wax ups, measuring posteriorly your wax up to make sure that it's the same in the mouth. So this measurement here should the whole 9 yards. So we went from that on an articulator, measuring again to modify and verify the bite through the whole process that we just showed you the first time. And we're going to do some gingival recontouring and all that, so this case even gets more complicated. But again, at the end of the day, jaw-to-jaw relationships depend, how well you do with that is going to dictate how well you do with the case. So when you're all said and done, yeah, some implants are going in, there's your temporary restorations and your final restorations. It's a lot of work, as you can imagine. All right, so there's where you're at with the final restoration, digital driven, but that's the concept of where we started and where we ended up. All right, so is it possible today to do a digital byte transfer? And what do I mean by that? In simplest terms, never put the case on an articulator. And I don't think anybody thinks that's possible except for a couple of us. And I know it's possible because we've done it. So you want to get rid of the wax rims, the sloppiest part of the whole byte transfer process. Can you get rid of the articulator, get rid of the wax rims, and use what's available in digital dentistry today to do all this without ever transferring a byte on an articulator? And let me just show you kind of how it works. And we'll show you the video here first. So radiographic alignment markers, they're short for RAM. It's patent pending. So if you had a case here with a bunch of teeth, and you're going to eventually take all the teeth out and replace them with implants. These are radiographic markers, kind of like TADs used to be, where you'd screw them through the tissue, and they could stay in there for up to 6 months. So now you have 3 radiographic markers on the top and 3 on the bottom. Teeth come out, implants go in. At some point you're going to take impressions and pick up the radiographic markers, either digitally or otherwise. And you have your 3 markers now on the CT scan. Teeth go away. Your STL file of the arch with the radiographic markers. Merge the 2 together. And now you have your jaw-to-jaw relationships. And digitally, Patrick then can make the final restorations without ever having the case on an articulator. So again, there's lots of advantages of this. You have the initial teeth that you have scanned in. So when he's designing and machining or designing the final restorations, what you didn't like about the initial teeth, you can take away. And again, it takes a pretty skilled laboratory technician to go through this whole thing digitally, but the software is advanced enough that it can be done. So it's pretty dramatic. It's both radiographic alignment markers are both patent pending and they're also FDA pending. So they're not available yet, but I think it's pretty exciting to me because I think it could literally change not just implant dentistry, but how we do dentures, how we do full mouth rehabs. And I will tell you with the cases that we've used it for, without FDA approval, the bites are deadly accurate. They're way more accurate than any system I've used before because, again, you take away all the variables of byte transfers and measuring and duplicating that measurement and transferring that measurement to the laboratory and them duplicating the whole process. It is dramatically different. So again, that's what's coming. I don't know how long it'll take to get it available because obviously it can't used publicly until we get through the patent pending process and the ADA approval process. But basically, it's those little the appliances are implants, and it's going through FDA process as an implant. All right. So anyway, that's the whole conversation that I wanted to talk about today. I guess I'm here to help you. If any of this was interesting to you and you want to dive a little bit deeper, or you have other things that you want to talk about, you want to turn the camera on, Tom? Have other things that if you have other things that you want to talk about, why don't you email me your considerations, your concerns, and I'll put together another presentation probably next Wednesday at 1 o'clock. If you have specific questions you want to talk to me about just individually, certainly we can do an online video chat, just a private one between the 2 of us if that helps you. But I have a whole lot of time that I didn't have with this COVID-19 thing, and I'd like to be as helpful as I can. All right, so next Wednesday we'll do another one, and it'll be only on whatever you ask for, you that are listening, or whoever else asks for something we'll include into that presentation. We'll send you an invitation as well. So thank you. Questions? Anybody send in any questions? The question was, is there a way to get the implants without the transfer? That's a great question. Actually, it's another thing we're working on. It's a bigger change than you think it is. We actually have designed the parts and pieces to do that. What we have to do, though, is we have to go through packaging and sterilization and validation to sell it. So it's a process we're involved in. Again, I don't know exactly how long that'll take. because the product's already done. We have the drivers and whatnot to do that. We are planning on selling an implant. It will be a less expensive implant because the driver won't be on it, the transfer. So we're going to sell an implant without the transfer on it with a attachment to drive it in place. So that is coming. It's just not available yet. And I can't really tell you when it'll be available because we have to, like I say, get it through packaging, validation, sterilization. The FDA is not an easy institute to work with, and it's really dependent on their time frame. And they're kind of busy right now, as you might expect. All right, if that's it, and nobody has their mic on to ask one, we'll call it a wrap. Thanks, guys. I appreciate your time. Again, stay healthy. Thanks for tuning in, and let me know if there's anything else I can help you with over the next few weeks, and hopefully we'll all get back to work. Thank you.